We're given a correlation coefficient, and we're given a sample size, and we're supposed to find a critical value. Remember, with what we've done with critical values before, we found like critical values for z and for t. These are values that we look them up in a table so that we don't have to actually calculate an integral, like an area under the curve. That's bad x-axis, but yeah, if you look up like a critical value for like 0.05, that means you want like 0.05 in one of your tails, and it tells you the area under the curve, or vice versa. It'll tell you like that. It'll tell you the value that gets you the area under the curve that has 95% over here. The big idea is that if you need a critical value, instead of having to do calculus every single time, we need tables to help us find those. Okay. So this is the same type of thing as what we did with z and t, like I was saying, except you just need a different table for r. Okay. We have r equals 0.543 and n equals 25. The degrees of freedom for correlation analysis is actually n minus 2. Okay, we have two columns of data going on. So, oops, I can't do something about it. 23 is going to be our degrees of freedom for this one. Okay, and then whenever we look up a critical value, we want to think, is it one-sided like I just drew a second ago, or is it two-sided? Does it have two tails? And so let's read through. Usually you get that from the problem, like it's asking test to see if it's a positive correlation. That's a one-tailed test, a right-tailed test. If it's a test to see if it's a negative correlation, that would be a left-tailed test. But this one just says to find a critical value. It doesn't specify, and all the answers have plus or minus, so that indicates we got a two-tailed test here. So you could look up a table in Google. You could use the table in your back of the book. What I always do with these problems when I need a critical value is I type percentile to actually, this is probably better, critical value calculator for r. And if that doesn't come up, you could type critical value for correlation coefficient. Let's try the first one that comes up in Google. And this is for t, this is for z, this is for chi-square, this is for f. So here's our critical value for r. We need to put in 23 for the degrees of freedom. And it's saying it's going to give us a one-tailed result. Right? We just said ours is two-tailed. And since we need a significance level of 0.05, we have to split that up evenly. 0.25 goes over here, and 0.025 goes over here. So what we need to type in for the critical value is 0.025. And that will give us our two-tailed value for 0.05. And so there's our critical value, 0.396. So since our test statistic, the r we got is 0.543. That's beyond the 0.396 we just found in our calculator or in the back of your textbook. So that means it's a significant linear correlation. It's beyond the critical value. If r was like 0.145 here, that's not beyond positive 0.396, so that would mean there's no significant correlation.